Unit 1A, Lesson 3. This aligns with 7.2 and 7.3 in your textbook. There's two main standards we're going to cover in this lesson. The first one, given a rectangle, parallelogram, trapezoid, or regular polygon, describe the rotations and reflections that carry it onto itself. The other one is develop definitions of rotations, reflections, and translations in terms of angles, circles, perpendicular lines, parallel lines, and line segments. That's kind of what we talked about in the last lesson. So we're also going to talk about rotational symmetries and line symmetries. First, we're going to discuss line symmetry. This occurs if a line can be drawn through an image so that a mirrored image is created on both sides. Okay, that line is called the line of symmetry. Lines of symmetry occur most often if we're talking about regular polygons. For instance, if we have an equilateral triangle, meaning all three sides are the same length, all three angles are the same, 60 degrees, there's going to be three lines of symmetry. If we start at one vertex and go perpendicular to the opposite side, that's one line of symmetry, and then the same for the other vertices as well. If we have a square, four-sided regular polygon, there's going to be four lines of symmetry, the two going through the opposite sides, and the two diagonals of the square. Same thing's true for a regular pentagon and regular hexagon. A regular pentagon has 5 lines of symmetry. A regular hexagon has 6 lines of symmetry. Okay, line of symmetry creating that mirrored image on both sides. The other type of symmetry we're going to discuss is rotational symmetry. This occurs if an image can be mapped onto itself by a rotation of 180 degrees or less. Okay, so if we look at this equilateral triangle, if I would rotate this 120 degrees, that was fairly close to 120 degrees, and now we look, that looks like the original image we started with. Okay, we can't distinguish what we started with what we have now after rotating it 120 degrees. Okay, so 120 degrees is less than 180, so this has rotational symmetry. We could also rotate this another 120, so we have a total of 240 degrees that's been rotated, and again we can't distinguish what we started with what we have now. If we look at this picture at the right, this also has rotational symmetry. If we start with the top and then now we go counterclockwise 90 degrees, this looks like the same image we just started with. Okay, rotational symmetry, rotated at 90 degrees. We could rotate it 180 degrees or 270 degrees, and we wouldn't be able to distinguish what we have now with what we started with. That's called rotational symmetry. In this first example, we want to draw all lines of symmetry for this equilateral triangle. We already discussed equilateral triangles when we introduced line symmetry before. What we need to do is go through a vertex perpendicular to the opposite side. So if we start with this vertex down here and go perpendicular to the opposite side the best we can, if we would create this mirrored image, flip this triangle on top of itself to the other side, we would have the same shape. So now if we start at this vertex, go perpendicular the best we can to the opposite side, this isn't going to be perfect. Again, we would create an mirrored image on both sides. The last one, start at the top, perpendicular to the other side. Again, we would have that mirrored image on both sides. So this equilateral triangle has 3 lines of symmetry. In this example, we want to determine which of the following transformations carry this regular polygon onto itself. So we have 4 different choices. There might be more than one right answer. We're going to determine which one of these choices is going to work. First, we need to think about a complete rotation is 360 degrees. Okay? We're looking at this regular polygon, equilateral triangle. There's 3 sides, so if we divide that by the number of sides, which is 3, we're going to be left with 120 degrees. Okay? So when we have a regular polygon, you can usually do this trick. We know that if this is going to have rotational symmetry, that it has to occur in increments of 120 degrees. So looking at our choices, we know the first choice cannot work, a rotation of 90 degrees, and the third choice is not going to work, a rotation of 45 degrees. The second choice, rotation of 120 degrees clockwise, that's going to work, as well as 120 degrees counterclockwise. That will work as well. Okay, it doesn't matter if we rotate it 120 degrees clockwise, counterclockwise, this is going to lie on top of itself because it's a regular polygon. In this example, which of the following transformations carry this regular polygon onto itself? We're going to use the same trick we used last time. We know a complete rotation is going to be 360 degrees. This is a regular polygon, so all the sides are the same. There's 5 sides. So if we divide this by 5, that's going to be 72 degrees. So since this is a regular polygon, if we rotate it about in increments of 72 degrees, this image is going to lie on top of itself. So if we look at this first one, a rotation of 144 degrees counterclockwise, well, 144 is a multiple of 72 degrees. 72 plus 72 gets us 144, so that would work. Rotation of 270 degrees clockwise, 270 is not a multiple of 72, that one's not going to work. Rotation of 288 degrees counterclockwise, that again is a multiple of 72, 72 times 4 is 288, so that would work. This last one, a reflection across line L. So if we take a look, that is a line of symmetry. It's also in this case acting as a line of reflection. If we would rotate about that line, we're going to get that mirrored image. So this shape, this pentagon, is going to lie on top of itself. That one is going to work as well. So 3 of the 4 choices, the rotation of 144 degrees counterclockwise, rotation of 288 degrees counterclockwise, and a reflection across line L are all going to carry this regular polygon back onto itself. This last example, we want to determine which diagram shows triangle PQR rotated 90 degrees counterclockwise about Q. So right away we're going to be able to eliminate 2 of the 4 choices. Since this is rotated about point Q, our pre-image and image are going to share that point. So if we look at the bottom left choice, we have Q prime and Q. Those are not lying on top of each other. They're not sharing that point. So that choice is not going to work. Same with the bottom right. Q and Q prime should not be separate. If it's rotating about that point, they share that point. So now we got to focus on these 2 choices above. Keyword here is now going to be counterclockwise. So if we're starting with the purple triangle, we need to rotate counterclockwise, which means this first choice does not work. That's rotated clockwise. So the only option that's going to work is the top right one. So if we take this image, rotate it 90 degrees counterclockwise about point Q, that is the image we would end up with. To conclude, in this lesson we discussed line symmetry, rotational symmetry, as well as determined which transformations can be used to carry an image back onto itself.